Hello everyone, welcome to Code Hub. Today's problem is construct binary tree from preorder and inorder traversal. Given two integer arrays, preorder and inorder, where preorder is the preorder traversal of binary tree and inorder is the inorder traversal of the same tree. Construct and return the binary tree. Okay, this is a straightforward standard interview problem. Let us solve today's LeetCode challenge as well. Pre-order of the, let us take this binary tree. Consider this binary tree. What is the pre-order? Pre-order is nothing but, let us say the traversal as well. Pre-order is nothing but root, then left, then right. What will be the in-order traversal? In-order is nothing but first left, then go to my root, then right. So for this binary tree, given pre-order in order, we have to construct the tree itself. So what will be the pre-order traversal for this given binary tree? Let us write it. For this binary tree, the pre-order traversal is first root. First we have written the root. We will write the root 3. Then it will go for right. After going for right, we will write 9. 9 is my root. Then I will be going for right. Right is null, left is also null. Then we will come back recursively and we will go to my this right. We will write its root. Now the 20 is my root. And then again I will go to left. After going to left, this is my root. So 15 is my root. And after going left, it is null. Right, it is null. Sorry. Then it will go to its go back, and 20 is right. 20 is right is 7. So on 7's left is null, right is null. So this is my pre-order traversal. So let us write the in order as well. In order, as we know, it will go first left. 3 is left, 9 is left is null. Then it will go to its root. We will write 9. Then it will go to its right. Right is null. So it will come back. We have processed the 3's left subtree. So now we have to write 9. Right is our root. Then what is left? We have to go to its right. 3's right. Then again we should go to our left. Again we should go to our left. Left is null. Then we have to write the root. Root is 15. Then it will go to right. Right is null. Then it will come back. After coming back, 20 is my root. So I will write 20. And then it will go to right. And after coming to 7, it should go to left. Left is null. We will come back and write 7. Then we will go to its right. Right is null. So this is my in-order traversal 9, 3, 15, 27 and pre-order traversal. This is 3, 9, 20, 15, 7. Given this pre-order and in-order, we are going to construct the tree. How we can construct? As you can observe that pre-order traversal, first it goes and search for its root, then it goes for its left, then it goes for its right. So always 3 is going to be a root of our binary tree. You have to accept it, because 3 is our root of the binary tree, because in pre-order we print the root first. Then 9 will be our root of the next left subtree. Then 20 will be a root of the subtree, but we cannot say it is left or right. So for that concern, to locate the whether this 20 is following the roots left or roots right, we are going to use the in-order traversal. So so 3 is our root of the binary tree. We have to locate the position of 3 in order traversal. So 3 is at this position. So the nodes which are to the left of the in order to the left of 3 are the nodes that are left subtree of 3, and the nodes that are right of this 3 comes under the right of the right subtree, right nodes of the subtree. That makes sense, right? So you can see that 3's left is 9 and 3's right is 20, 15 and 7, as you can see here. So we can so what we can do here is, the steps we can follow here is, first choose the root node from the pre-order, After pre-order, we have to find the location of the node in that in-order traversal. So consider we are at 0, 1, 2, and it is 3 and it is 4. So this is the nodes value. So we have to somehow locate this 3 in order traversal, and we have to give the position of the next nodes in order. So 0 to 1 becomes my in order for this 9th node, and for this 20th node, what will be my left subtree? Consider and say. So the node, the left node of the subtree, the left subtree of this 20 is nothing but 15, which is 2 to 3. So the right node of the 20 is nothing but 7, which is 3 to 4. So if we can give the ranges for the left and right subtree, then we can do this recursively and solve this problem. So we can first what we can do is choose the root node from the pre-order traversal. Then pick the index of the root node from in order. After picking the index, we can say we have to create the node also. Create the root node. After creating the root node, what we can say is root of left is nothing but this. Consider this picked index. This is my picked in order index. I will say it as in index. So in order index. So the root of left is nothing but the start index to my end index. And what will be my root of right? Root of right will be nothing but in index plus 1 to end index. So you can say this. Can you say this? Yes, you can say this. Root of left is this, root of right is this. So this will be the, so these are the ranges that I'm going to give to my next recursive call for to take that as in order and pre-order for that particular node. That makes sense. So let us do the and finally we will just return our root. So we will just define the recursive function and we will build our tree. How we can build our tree? First we have to create a map. Since why we have to create a map? We have to pick the index of that particular value. So we can create a map. For that we can declare a map unordered map of int comma int, and I will say it as in order indices. So that it makes sense. In order indices. So I will map those values with their indices. Int I equal to 0, I less than n. N is nothing but size of the pre-order or in order, both are same, pre-order size. Then I plus plus, inside which what I have to do is in order or indices of I. I will say it as val. In order of val is nothing but I. Int val is equal to in order of I. Hope that makes sense, right? So I'm just mapping those values with their indices. After mapping, what we have to do? We can call the recursive function. I will name the recursive function as construct tree. I will pass pre-order, then in order, then I will pass the in order indices as well, and I will pass start index, and I will pass the end index. End index is nothing but the size of the array n, and I will also pass the for each and every recursive calls, my root nodes are the next index of this pre-order. For my next recursive call, the 20 is my root node. For next recursive call, 15 is the root node. So I should pass one value that is going to iterate once in this pre-order. So I will name it as int pre-index, or I will say it as root index, which is nothing but it starts from 0. I will pass this root index. Since I am going to pass this value as reference, I am having a variable, and I will write a private function, which is construct tree. This is going to give me a tree node type construct tree, and we can just copy paste this preorder, then Inorder, then I also need an Inorder indices. I will pass this also by reference. I don't want to make another copy. Then what I need? Then I need a start index, int start index, and I also need an end index, and I also keeping track of the root index of this preorder array. Root index. Yes. Now we have defined the function. What I can say is, if my start index is greater than or equal to my end index, then I can just return null. This will be my base case. Okay, fine. Then now I have to create a new node, tree node star root, which is nothing but new tree node of preorder of pre-index. Instead of getting complicated, preorder of pre-index, I will store this value in one variable, root val, which is nothing but preorder of pre-index. After creating a root node, I can just increment this pre-index for my next recursive call. And now I have to get the index, get the position of the root node, so getting the position of root node from Inorder array. So what we can do is int position. I will say it as position. Int position is nothing but the Inorder indices of my root val. Okay, I have got the position also. Now what we have to do is root of left, I have to do some recursive call, which is construct tree of, I will call preorder. So we are passing preorder, then Inorder, then this Inorder indices, then the start index. From my start index, I have to take position till my position as my Inorder for my next recursive call, right? Yes. Then I will also pass the pre-index as well. I will pass this root index. I have messed up with some variable naming. Root index, and this root index. Fine. Now I will also pass the root index. Again, we have to fix the root of right. Root of right is nothing but the same construct tree, but changing the ranges alone will make our work easier. It starts from position +1 till my end index. So this range will be my Inorder for my root of right. And finally, what we are going to return? We are going to return root. Hope this helps. Let us run our code. We are fixing the root of left and root of right in our recursive calls. That's what we are doing. Okay. What is the runtime error? Let us see. Yes, the values should be affected here in Amazon root index. So let us rerun our code. Before that, I will also change this to root val to make the code look nice. I am passing it as reference. So it got accepted. We will use the example test cases as well. Superb, it got accepted. So let us submit our code. So what will be our time complexity here? The time complexity will be order of n. And what will be the space complexity? Since we are creating a whole n tree itself, we will be using an order of n space. So we have solved this today's LeetCode problem. Hope hope you all find it helpful. So let us see in tomorrow's LeetCode's daily challenge. Bye.